This is the core concepts mock exam. We're on to this is mock exam 1 and question 6, which is the essay. If you were drawing clouds for this essay, you need your usual, sort of 3 clouds, and you need to look at what we've got. What information does it give us? So 3 related molecules from the same biochemical group. So, for example, 1 protein and another protein, same biochemical group. 1 carbohydrate and another carbohydrate. But if we had a protein and a carbohydrate, there would be 2 different chemical groups. So these we know our biochemical groups, proteins, carbohydrates, lipids, nucleic acids, and we need to realise that that's what we need. So we're not going to mention any of the others once we've decided which one it is. And we've got similarities, so that would be a kind of cloud there. Differences in their structure, so these 2 clouds both relate to their structures, and we've kind of got functions within cells. So what have we got? So if we just look at what we've got 3 triglycerides, lipids. So that's our same biochemical group. Okay, so these are lipids. And so now we're not going to mention proteins, carbohydrates, nucleic acids or anything like that. These are all lipids. What we've got here, we've got a lipid with fatty acid chains that are unsaturated. In B, these are saturated, and C, we've got 2 fatty acid chains, and we've got a kind of phosphate group. So this is a phospholipid. Similarities. So here we go with similarities. I'm not going to write all of this down really. I'm just going to show you on here. So similarities. We have got glycerol. Okay. So what used to be glycerol there. Okay. Now we've got the same thing there, and we've got the same thing there. Okay. We have got these ester bonds there, and we've got ester bonds there, and a sort of similarity. We've got ester bonds there, but not the third one. Okay. Similarities, well, we've got fatty acid chains on each of them. They were all made, in condensation reactions, joining the fatty acids onto the glycerol. So those are the similarities. Differences, we really wanted to highlight in the structure. We've got these unsaturated, and in fact it's many times as this, so it's polyunsaturated, you might have heard that there. Whereas in molecule B, these are totally saturated with hydrogen. So saturated means it's got single bonds only, and there's as many hydrogens as you can fit onto the carbons. Whereas in our A, unsaturated, which means it's got carbon to carbon double bonds, so not as much hydrogen. And in molecule C, we can see we've got 2 saturated chains, and we've got the phosphate there. Okay. In terms of properties, A, for our unsaturated, with our double bonds, then we associate this with being kind of an oil or liquid at room temperature. So we're now going into kind of functions. So this affects the boiling point and so on, melting point. So we're looking at oils, liquid. And where do we find these? We find these in plants, and particularly things like for energy storage in plants. So energy storage. So sunflower oil, in sunflower seeds, energy storage, and you can squeeze sunflower seeds and oil will come out if you squeeze them hard enough. Or if you squeeze olives, oil will come out of those. And we could extend this a little bit and say, well, if, when you're eating these, it raises your HDL levels. Good for you. Removing those plaques that you get in your arteries. So it's traditionally associated with a healthy diet, a plant-based diet. And B, this is our saturated, so saturated with hydrogen, no double bonds, only single bonds. This is solid at room temperature, and it's associated with energy storage in animals. So we've got energy storage in plants for A. This is same sort of use, energy storage, but in animals, in things like adipose tissue, and those kind of fatty tissues. And if you cook meats at home, quite often if you have a beef burger or something like that, then what you've got left when you're ready to do the washing up is kind of solid chunks of fat left in the pan, whereas if you were eating something with olive oil, that would still be liquid. So this is much associated with being solid. What do animals actually use this for? So energy storage, but all sorts of other list of things. You get this tissue packed around your delicate organs, your heart and so on, and kidneys. Things like thermal insulation, buoyancy, helping things float, animals float. So those sort of things from your notes, that's what you're looking at. And you might even mention energy storage, the use of using fats as opposed to carbohydrates, so we're getting more energy from our fats. And then with our last one, our phospholipid with a phosphate head, well, this is much more different, and we're associating this with phospholipid bilayer. And there were some questions earlier on involving that, and we're saying we've got a hydrophilic head and hydrophobic fatty acid tails. In fact, and this because these bonds are flexible and can rotate, then this head would move away, so it'd actually be on this side. And you can then this tends to form bilayers. If you've got water on each side, then we get hydrophobic areas pointing together, so we get hydrophobic areas in the middle of the fatty acid tails, and you get another on the other way, and then have a kind of a watery environment on each side. So the tails face away from the water. And you could then suggest reasons why this was useful, to regulate what goes in and out of cells. For example, lipid soluble molecules can diffuse through this layer and so on. So for marks wise, at the top you don't need to be perfect, but you do need to mention most of those areas that we've talked around and identify these three different, the unsaturated, saturated and phospholipid. We're looking for at least one similarity and difference between these top two, and a bit of explanation. And there's loads of things you could say there. If you can only think of one or two things for molecule B, then you don't deserve the top marks for this. In the kind of middle band, then you should be able to identify them and describe, but maybe not in as much detail. And in the bottom band, for the lower marks, kind of 1 to 3, you're telling us some general marks about fats, but you can't associate the right words with these structures. And some people have just described these without any kind of terminology and actually got 0, because that's what a person in the street might be able to do. So here your revision will get you 9 marks.